Okay, hello, dear colleagues. So today we have the defense of the dissertation of Nursapina N Arman Kızı on her topic, entering of natural radionuclides in soil and root crops with fertilizers and their distribution in soil plant system on the specialty chemistry. Scientific supervisors, Matveeva Ilona Valerievna, PhD, Associate Professor of the Department of General and Inorganic Chemistry of Al-Farabi Kazakh National University, Almaty, Kazakhstan, and Marko Strok, PhD, Head of the Radiochemistry Laboratory at the Joseph Stefan Institute, Ljubljana, Slovenia. The dissertation was performed at the Department of General and Inorganic Chemistry of Al-Farabi Kazakh National University. So temporary members of the dissertation council are Dagmara Struminska, PhD, Associate Professor, Faculty of Chemistry, University of Gdańsk, Poland. Fotini Noli, PhD, Associate Professor in Radiochemistry, School of Chemistry, University of Thessaloniki, Greece. Klivenko, Alexey Nikolaevich, PhD, Head of the Scientific Center for Radioecological Research, Shakarin University, Kazakhstan. Official reviewers, Krasnoperova Marina, PhD, Senior Researcher at the Low Background Measurements Laboratory, Center for Integrated Environmental Studies, Institute of Nuclear Physics, Almaty, Kazakhstan. Adomskaya, MA, Candidate of Biological Sciences, Head of the Laboratory of Radiochemistry and Analytical Chemistry at the All-Russian Research Institute of Radiology and Agroecology, National Research Center, Kurchatov Institute, Obninsk, Russian Federation. Okay, so we have all temporary members and all official reviewers. Yeah, we have 3 permanent members of the dissertation council. Dr. Galeva is absent, so I am the vice head of the dissertation council, and I will be leading today's defense. Okay, so before we start, I just remind you that we have 4 possible decisions of the council. First is to award the degree of PhD. Second is to send the dissertation for revision. Third is to recommend to send the dissertation for redefense. And the fourth is to refuse to award the PhD degree. Okay, so I remind you that we have the recording of the defense and the online broadcasting on YouTube at the university channel. So please keep your camera on during the defense. And the floor is given to the scientific secretary of the council, Professor Uralbekov, to present the documents available in the applicant's personal file. So please.
Hello, dear dissertation council members, colleagues. So give me this opportunity to tell about Nursapina and the documents we have. So Nursapina Arman Kızı, born in 1994, studied at Al-Farabi Kazakh National University. It's Almaty, Kazakhstan, from 2012 to 2015. Earning a bachelor degree from the Faculty of Chemistry and Chemical Technology in the specialty Chemical Technology of Inorganic Substances. In 2015, she was admitted to the master program at the same university in the specialty 6M072000 Chemical Technology of Inorganic Substances. Successfully completed her studies in 2017. From September 2019 to May 2022, Nursapina admitted to doctoral studies at Al-Farabi Kazakh National University, and in June 2024 she has re-enrolled in the third year of doctoral program on the educational program chemistry. The dissertation topic and academic supervisors were approved by the Academic Council of our university. So all documents of Nursapina Arman Kazan Nurgul included copies of her bachelor and master diplomas, list of copies of her publications, positive evaluation of her supervisors, local supervisors, foreign supervisors, conclusion from the department regarding the dissertation, and all other documents in accordance with regulation of Committee for Quality Assurance in the sphere of science and higher education of Ministry of Science and Higher Education of the Republic of Kazakhstan are available. As a part of her dissertation research, the PhD candidate has published one paper in journal indexed in Scopus and Web of Science, 3 papers in journal recommended by our committee, and 1 monograph and 6 conference abstracts. On April 30, 2025, Nursapina dissertation work was discussed during extended meeting in Department of General and Inorganic Chemistry at Al-Farabi Kazakh National University. In this meeting, 32 participants attended. The first reviewer, Uralbekov Bulat Muratovich, professor of this department, provided a positive review and listed 4 comments. The second reviewer, Alimjanova Merike Baujan, PhD candidate of chemical science, associate professor at Al-Farabi University, made 6 observations in her review. So the responses were provided to all questions and comments raised by reviewers. And this research seminar held during this extended department meeting, highly evaluated this research work and recommended this thesis for further defense, noting the novelty of the obtained results and their practical significance. By the protocol number 19, this seminar was approved by our Vice Rector for Scientific and Innovation Activities, Margulan Kasyanov Ibragimov. And our dissertation council approved May 27, approved the temporary members, and finally our dissertation council approved official reviews and the date of defense. So that's all I have. If you have a question, I'm ready to answer.
Okay, thank you. Dear colleagues, do you have questions to Scientific Secretary? Okay, if there are no questions, the floor is given to the PhD student to present the content of the dissertation. So the deadline is 20 minutes. So please, the floor is yours.
Good afternoon. Let me introduce the topic of my dissertation work is the entering of natural radionuclides in soil root crops, fertilizer, and their distribution in soil plant system. The intensification of the agriculture and widespread use of the fertilizers lead to the introduction of natural radionuclides into the soil and change in their geochemical behavior. The transfer of radionuclides in soil plant system has been studied globally. However, the impact of fertilizer on mobility and bioavailability of radionuclides remain insufficiently addressed. The purpose of the work is to establish effect of application of fertilizer on accumulation ability of radionuclides in root vegetable, carrot, and radish. The task of the thesis, first, to select the fertilizer commonly used in agriculture practice of Kazakhstan. Second, to perform experiments of cultivation of carrot and radish on soils which will be enriched by different type of the fertilizers. Third, to determine the activity concentration of natural radionuclides of uranium and thorium series in fertilizer, soil samples, and vegetative organs of carrot and the radish. Fourth, to evaluate the soil to root vegetable transfer factor of natural radionuclides for carrot and radish cultivated with application of various fertilizers. Fifth, to evaluate the effect of fertilizer on distribution of PGA chemical forms of natural radionuclides in soil. 6, to evaluate the effect of fertilizer on activity ratio of natural radionuclides in the studied sample. The main provision for the defense. First, the total activity concentration of uranium-234, uranium-238, thorium-230, thorium-232, and radium-226 in monopotassium phosphate, ammonium nitrate, superphosphate, double superphosphate, phosphoric, organomineral mixture, and NPK fertilizer, microfertilizer, and pit fertilizer did not exceed the limit value of 1,000 becquerel per kilogram according to the technical regulation of Euro-Asian Economic Union. Second, the application of monopotassium phosphate to soil sample from the Biterek village increases the proportion of mobile uranium and leads to the increase in the accumulation of uranium in the edible root of the radish. Third, the application of double superphosphate to soil sample from the Kazamshek village significantly increased the transfer and accumulation of uranium isotope and radium-226 in the edible root of the carrot compared to the unfertilized soil. The experimental work was started from the soil sampling from the two different regions of the Kazakhstan. Two soil sampling site was located in Almaty region, in Biterek and Koklaksay village. The specific attention was paid to this region since one of the megacities with the huge population located here. The third soil sampling site was located in Turkestan region in Kazamshek village, which is located close to the near former uranium deposit site. The vegetation experiment starts with the seed treatment and germination, as the seed was chosen the seed of the radish and the carrot, which is reflect the common dietary preference of the population of Kazakhstan, with following soil preparation and pot setup and fertilizer application. 9 different fertilizers was tested. After that, planting and growing under open environment condition with harvesting and sample processing was carried out. After the vegetation experiment, soil, root crops, fertilizers was pre-treated, air dried, homogenized, and etched for the analysis of the radionuclides. In case of the soil, in order to determine mobile and potentially mobile fraction, sequential extraction was applied. In case of the fertilizers, simultaneous thermal analysis and K0 instrumental neutron activation analysis was applied. Method validation was performed using the standard reference materials, and obtained value was in good agreement with the certified value, where the EN score was acceptable. Activity concentration of natural radionuclides in investigated fertilizer was lower and did not exceed the limit value of 1,000 becquerel per kilogram. Among the investigated fertilizer, the highest activity concentration of uranium-234, uranium-238, thorium-230, radium-226 was observed for the phosphoric fertilizer. Meanwhile, in case of the thorium-232, is observed for the double superphosphate. Based on the result of the simultaneous thermal analysis of the fertilizers, can be concluded that fertilizers can be classified depending on their soluble fraction. For instance, monopotassium phosphate and ammonium nitrate contain inorganic soluble particles, which can be prediction of their solubility in water soluble fraction. Activity concentration of natural radionuclides in soil sample from the Biterek village fluctuated between the differently fertilized soil. Pedological parameters of the soil, such as the pH and organic matter, insignificantly change with the application of the fertilizer. In order to assess the potential impact of the fertilizer to radionuclide accumulation in soil, the zeta score was applied, and as you can see, in almost all cases, this score was was more than 2, which indicate statistical significance in change of the activity concentration after the fertilization. In case activity concentration of natural radionuclides in soil from the Koklaksay village fluctuated between the differently fertilized soil type. Organic matter and the pH insignificantly changed with application of the fertilizers. The Z-score was less than 2, indicating no statistical significance in change of the activity after fertilization. Activity concentration of natural radionuclides in soil from the Turkestan region fluctuated between the differently fertilized soil type. The pH and organic matter insignificantly changed with application of the fertilizer. The Z-score was less than 2, which indicate no statistically significant in activity change of the natural radionuclides after fertilization. Uranium fractionation in fertilized soil from the Biterek village. In case of the monopotassium phosphate, uranium belongs to the bond, mostly belongs to the bond to organic matter fraction, which belongs to the potentially mobile due to the formation of the soluble uranium organic complexes. In case of the ammonium nitrate fertilized soil, uranium equally distributed in the bond to organic matter fraction and the bond to ferromanganese oxide fraction, where uranium possibly could be co-precipitated with the oxides. In case of the uranium fractionation in soil from the Koklaksay village, Uranium-234, uranium-238 mostly distributed in strongly bond and residual fraction, but application of the monopotassium phosphate, ammonium nitrate, pit fertilizer, microfertilizer lead to the increase of the distribution of the uranium isotopes in potentially mobile and mobile fraction in comparison to the unfertilized soil. The noticeable change was observed for the ammonium nitrate fertilized soil, where the percent of the distribution of uranium isotopes increased 2.6 times in potentially mobile and mobile fraction in comparison to the unfertilized soil. In case of the thorium-232, they mostly belongs to the residual and strongly bond fraction, where the thorium can be fixed in the crystal lattice of the minerals and be immobile. In case of the radium-226, the noticeable change was observed for the soil with application of the ammonium nitrate, where the distribution of radium-226 increased in bond to carbonate fraction in comparison to the unfertilized soil. Fractionation of natural radionuclide fertilized soil from the Kazimshek village. In case of the uranium-234 and uranium-238, application of the monopotassium phosphate, ammonium nitrate, lubazerinol or NPK fertilizer, double superphosphate phosphoric, pit fertilizer, and microfertilizer lead to the increase of the distribution of uranium isotopes in bond to carbonate fraction. This could be possibly related to the pH change. For instance, at alkaline pH, uranium form carbonate forms, which could be resulted in increase of the bond to carbonate fraction. In case of the thorium-230, thorium-232, they are mostly belongs to the strongly and residual fraction, but application of the ammonium nitrate in case of the thorium-232 increase the application of the ammonium nitrate, lubazilin, double superphosphate, and microfertilizer increase the distribution of thorium-230 in potentially mobile and mobile fraction in comparison to the unfertilized soil. In case of the thorium-232, noticeable change was observed for the double superphosphate, where the application of the double superphosphate increased the distribution of thorium-232 in mobile and potential mobile fraction up to 59%, where thorium-232 mostly distributed in the ferromanganese oxide fraction. In case of the radium-226, application of monopotassium phosphate, lubazilin, and double superphosphate phosphoric microfertilizer lead to the increase of the distribution of radium-226 in bond to carbonate fraction in comparison to the unfertilized soil. This possibly could be related in case of the phosphate fertilizers with extra addition of the calcium, magnesium, and carbonate ions with the fertilizers, where calcium and magnesium ions can compete with the radium for the exchange site for the minerals and ferromanganese oxides, which could be resulted in decrease of the fraction of the bond to ferromanganese oxide and increase of the fraction of the bond to carbonate. Activity concentration of natural radionuclides in radish grown on soil from the Baiterek village was the highest activity concentration was determined for radish, which was cultivated with application of the monopotassium phosphate for all investigated radionuclides. In case of the carrot grown on the soil from the Koklaksai village, the highest activity concentration of uranium isotopes was observed for monopotassium phosphate fertilized soil, ammonium nitrate, microfertilizer, and pit fertilizer. And the same trend was observed for the thorium isotopes and radium-226. In case of the carrot, which was grown on soil from the Kazimshek village, the highest activity concentration of natural radionuclides was determined for the carrot, which was grown with the application of the double superphosphate. In case of the soil to root vegetable transfer factor for the radish, which was grown on the soil from the Baiterek village, the highest TF factor was observed for the carrot, which was grown with the application of the monopotassium phosphate for uranium-234, uranium-238, and the thorium-230. TF exceed the value of the 1. In case of the carrot, which was grown on soil from the Koklaksai village, the highest TF value was determined in case of the uranium isotopes for monopotassium fertilized soil, ammonium nitrate, pit fertilized, and microfertilized. And the same trend was observed for the thorium isotopes and radium-226. Nevertheless, the TF value did not exceed the 1. In case of the carrot grown on the soil from the Kazimshek village, the highest soil to root vegetable transfer factor was determined for the natural for the carrot, which was grown with the application of the double superphosphate. Regarding to the radioactivity ratio in soil from the Baiterek village, in case of the uranium-234, uranium-238 ratio, was close to the unity. indicating state of the equilibrium and no effect of the fertilizer to this ratio. In case of the carrot, the uranium-234, uranium-238 ratio in reddish was more than 1, indicating more preferential uptake of the uranium-234. In case of the Koklaksai village soil, in case of the uranium-234, uranium-238 ratio, it was also close to the unity, indicating the state of the equilibrium and no effect of the fertilizer. In case of the carrot, the application of the Lubazelina or NPK fertilizer, double superphosphate phosphoric fertilizer, lead to the increase of the radium-226, uranium-234, radium-226, uranium-238 ratio in comparison to the unfertilized soil, indicating enhancing of the radium accumulation. In case of the Kazemshek soil, in case of the Kazemshek soil, the activity ratio of uranium-234, uranium-238 was close to the unity, indicating equilibrium, indicating state of the equilibrium, and no effect of the fertilizer. In case of the carrot, the activity ratio of radium-226, uranium-234, radium-226, uranium-238 was lower for all investigated fertilizers in comparison to the unfertilized soil, indicating the decreasing of the radium-226 accumulation. Based on the results of the study, the following conclusion can be drawn. The activity concentration of investigated fertilizers is relatively low and did not exceed the limit value of the 1000 becquerel per kilogram. The highest activity concentration of natural radionuclides was found for the reddish growing on the soil, which was fertilized by monopotassium phosphate. The highest activity concentration of natural radionuclides cultivated on soil from the Kazemshek village was determined for the root crop of the carrot cultivated with the application of the double superphosphate. Evaluation of soil to root vegetable transfer factor revealed that application of monopotassium phosphate led to the increase of transfer factor of uranium-234, uranium-238, thorium-230 for the reddish. The application of double superphosphate fertilizer resulted in an increased transfer factor of uranium, thorium, and radium in the root crop of the carrot cultivated on soil from the Kazemshek village. Based on the sequential extraction of fertilized and unfertilized soil from Dalmat and Turkestan region, it can be concluded that the notable change in distribution of uranium isotopes was observed for the soil fertilized with ammonium nitrate. Thorium isotopes remain mostly immobile for all investigated samples. Application of ammonium nitrate led to the increased amount of the bond to carbonate fraction in case of the radium-226. In case of the soil from the Kazemshek village, application of the double superphosphate fertilizer significantly increased the mobile and potentially mobile fraction of the thorium-232. Evaluation of activity ratio of isotopes of natural radionuclides revealed that for all soil samples, the uranium-234, uranium-238 ratio remained close to the unity, indicating equilibrium and suggesting that fertilizer application has minimal impact to uranium isotope fractionation. The main results of the dissertation work was presented in 11 publications. This work was supported by the Ministry of Education and Science of the Republic of Kazakhstan under the grant and supported by the Erasmus Plus program, also supported by the ICTP IES Sandwich Training Educational Program. That's it. Thank you.
Thank you. So questions? Dear colleagues, do you have questions?
May I ask, please?
Yes, please. Dr. Klimenko?
Can you show us the slide with the provisions which you are defense? In the beginning, I think. Yeah. So the first provision for the defense, can you comment? I think it is so trivial because whole are studied by labs, and it should be without any exceed limits of value by requirements for mineral fertilizers. How you think about it? So the question is this provision trivial or not? From my point of view, it is so trivial because it is not should be to defense. It must be controlled by special organs.
Okay, thank you for the question. Regarding to this, regarding to this question, there is always exist the regulation which related to the total activity of natural radionuclides in the fertilizer, and in our case, it was the commonly used and available fertilizers in Kazakhstan. So in point of the on the practical point of the view, we can suggest the safer fertilizer use. So in my opinion, is not trivial.
Okay, thank you.
I have a question.
Yes, please.
How did you treat the plant tissue to ensure that you'd removed all the soil particles from the surface?
The plant tissue was treated according to the standard protocols. So it was washed by the, it was firstly cleaned by the ceramical knife, and after that it was truly washed with the distilled and be-distilled water.
Thank you. So the concentrations that and activities that you're reporting are relative to the dry weight. Did you also measure the moisture content of the vegetables?
Yes, the activity concentration presented for the dry weight.
Did you also measure moisture content?
Moisture content, basically it was, we can take the factors to recalculate for the fresh weight if the question was in it.
I mean, it might be interesting to see how the activities were different or concentrations were different relative to the moisture content of the plant tissue.
Okay, thank you.
Right, because that's the primary route of uptake would be proportional to moisture content.
Okay, we'll take it into account.
Can I ask a question?
Yes, please.
Okay, so I've got two questions actually, and the first one made maybe the comment, because thanks a lot for the presentation, because I can imagine it took a lot of work and separations mostly to achieve the data, and I know that it's very, very hard to get all this data and do this lab work, because the radiochemical analysis is very, very hard. But I've got, maybe this is not the question to the job, but maybe about the future. So do you think would be the impact on the leaves only or on the roots? Because you know you have the root veggies, so it can look a little bit different according to the leaves of the vegetables we would consume. And the second question is there something you would do in the other way after all the job you did and you know you got the knowledge? So is there something you would change, or you would go in the other way to achieve the data and you know do all the job you did?
Okay, thank you for the question. For the regarding to the first question, in our case was chosen the root vegetables, which is commonly, which is reflect the common dietary preference in Kazakhstan. And the root vegetables is good indicators for evaluation of the transfer factor, because they stay in close contact with the soil. And in case of the transfer from the root to the shoot is possible, of course, and we also see these factors. But in case of the carrot and the radish, usually the shoot of the carrot and the radish is not consumptible by the people.
Yeah.
So that's why we did not focus on that. Regarding to the second question, probably it will be in the future better to monitor the application of fertilizer during the longer period of time, or with application of different concentrations of the same fertilizers.
Okay, thank you.
Thank you. Other questions?
I have a question, please.
Yes, please.
So, congratulations for the work and the nice presentation. As I have seen, the activity concentration in some samples from different, using different soils was too different. For example, I remember that the uranium concentration was too high in some samples. Can you show us the slide? To see the difference in the activity concentration of the uranium accumulation.
Next, please. For the soil, yes? Mhm.
Yes.
Mhm.
How can you explain
The-
that? Because as I have seen, the activity concentration of uranium, okay,
Следующий.
in the soil is more or less
Мгм.
the same. Have you done a chemical analysis of the soil? Do you know the constituents of the soil, except of organic matter?
Okay. Regarding to the pedological parameters, these two parameters was chosen since they was based on the literature review and they reflect the common effect to the mobility and the bioavailability of the radionuclides. Regarding to the content, is different from to these two regions because one region was initially taken as the clean and one region was like contaminated. Basically, the soil from the Kazemshek village is located near the former uranium deposit site, so probably that's why there is the differences in the uranium concentration.
Okay, thank you.
Thank you. Other questions?
So, Vlad, Nurlanch, if I can ask.
Yeah, yes, please.
I know this work, but this is additional probably question. So you identified, let's say, a mobile fraction of isotopes, yeah? And is it possible to predict, for instance, in the future, how it can be bioaccumulated and the portion of bioaccumulated radionuclides by plants or by any other, let's say, livestock?
Yes, it's possible. Since the fertilizers, they could change the soil characteristic, especially with regard to the pH. And during the presentation, it was presented that in some cases, for example, application of fertilizer lead to the increase of the bond to carbonate fraction, which is belongs to the potential mobile fraction. And it can be mobile and bioavailable for the uptake by the different vegetables, but we have to also into account the type of the vegetables because it can be different pathways of the uptake.
Okay, the another question is about why you chose these natural radionuclides. I see that all of them have quite higher half time, yeah, but I mean half decay period. But what was the what was the reason for this radionuclides? For instance, potassium 40 can also contribute, or other.
Yes, the natural radionuclides was chosen since they are mostly presented in, for example, phosphate-based fertilizers, and they have not only radiotoxicity but also the chemical toxicity.
If it's chemical toxicity, it was you somehow tried to evaluate chemical toxicity.
not basically, we did not evaluate this because since mostly this evaluation regarding to the radioecological risk which related to the humans. So this is the mostly from the point of the radiological risk. Basically, during this work, we did not present it, but the first series of the studies, which was related with the radish, we have the published paper where we have these parameters like excess lifetime cancer risk. So
Okay,
basically we have
if you remember when I was a reviewer of your work, my question was also that there is a bit low chemistry. So probably it will be better, for instance, somehow to predict their behavior using chemical properties of the proper radionuclides. So probably now you can answer to this question. Yeah. What is the chemistry behind all of this radionuclide bioaccumulation?
chemistry mostly related with the condition of the soil. If the pH of the soil will change, or for example, application of ammonium nitrate could lead to the slightly acidification of the soil. The uranium will be dissolved, some form of the carbonates and the inexchangeable fractions. So there we have to take into account such parameters like the pH or organic content.
I'm actually asking about, for instance, we know that uranium is quite good complexing agent, yeah, while radium is not. So radium exists in a radium 2+, while uranium exists in a coordination of complex compounds. That I mean that if this chemistry we take into consideration, it somehow impact to their let's say geochemical form or accumulation or so on, or risk.
Yes, I agree with your comments. Yeah, uranium is mostly a good complexation agent for in comparison to the thorium, which is less mobile and less bioavailable due to the formation of the insoluble probably hydroxides or phosphates. And in case of the radium is also regarding to the chemistry, it can be also co-precipitated with sulfates or the carbonates.
Yeah, thorium also, you know that it's a really low mobile because of hydrolysis, yeah? Okay, thank you, Professor Kinesov.
Thank you. Thank you. Other comments, other questions, dear colleagues?
Yes, I have another question related to the thermogravimetric analysis. In your dissertation, you said you were going to use that to predict the mobility of the radionuclides in the fertilizer. But I couldn't find, maybe I just missed it. Was that a predictive tool for the amount of radionuclide that was taken up by the plant?
Simultaneous thermal analysis was applied since this is the one of the easiest way, and it was applied in the initial step when we was just analyzing the fertilizers, just to be sure that there is some components just could be soluble and could be mobile in some mobile or potentially mobile fractions of the soil.
But did it predict the amount of radionuclide that would be taken up?
Basically, we did not correlate these results, so this is not presented in the work.
Okay, thank you.
Thank you. Other questions?
It was Professor Dan Snow from University of Nebraska. So
thank you. Thank you.
Yeah.
It's nice that you introduced, because we just see you sitting without names. Okay, thank you. Other questions?
Let me ask Nurgul. I know that one of the complicated part of radioecological investigations is organizing of field visit expeditions. How did you do? How many people took part at the procedure? You did it alone? Maybe
No.
with your supervisor, or maybe students was accompanied you?
Okay. Basically, soil samples was collected between the 2019 and 2021. Since this work was done in the frame of the project, the soil sampling was, of course, not taken only by me. It was the group, our scientific group, which include 4 persons. And the soil sampling was collected according to the standard protocols. Yes.
Thank you.
Professor Kenesov, we finished with question
Uh-huh.
here at least.
Yeah. Okay, thank you. Any other questions? Because I have a couple of questions. Oh, yeah.
Okay.
Who?
Dan,
Professor
Daniel,
Snow? Uh-huh.
yeah, I'd like to
Yeah.
ask another question. Did you do a literature review on radioactivity levels in fertilizers worldwide, phosphate fertilizers? And if you did, how did the concentrations that you measure, the activities that you measured compare?
Yes, during the dissertation work, the literature review was done, and usually the higher activity concentration of the natural radionuclides is presented with phosphate-containing fertilizer. But we found the fact that not always the percent of the P2O5 is not always reflecting the concentration of the activity concentration of uranium, for example, and there is no always the correlation between them. So it can be that the fertilizer, the phosphate fertilizer, has the high concentration of the P2O5 but the less concentration of the uranium isotopes. And also, in case of the fertilizers, it's really depends on what kind of the raw materials was, in case of the phosphate fertilizers, what kind of the raw materials was used, and what kind of the production technology was applied during the obtaining these fertilizers.
Thank you. One last question. So based on your experiments, what would you predict would happen if those pots would be fertilized and you'd grow crops, say, over the space of 5 years? Would that change the uptake in the plants or stay the same?
Possibly it will, the constantly use of the fertilizer without any restrictions, probably during the 5 year could lead to the accumulation of the some radionuclides in the soil. And also we cannot predict the environmental changes during the 5 years, and it could also affect the soil chemistry and the bioavailability and mobility of the radionuclides.
Thank you.
Okay, thank you. So I have a couple of questions. First of all, is about the third provision for the defense, where you can state that the application of double superphosphate significantly increases the transfer. So how did you check the significance of the difference?
The significance was checked based basically on the transfer factor for the double superphosphate for the carrot, which was grown with the application of the double superphosphate. And you can see here on this slide that, sorry, this is the activity concentration. Yeah, the next slide. Here you can see that in case of the uranium isotopes and in case of the radium-226, the TF factor was more than 1, which usually in radioecological assessment present the higher accumulation of these radionuclides in the root vegetable of the carrot.
Okay, but what were the p values?
Sorry,
did you measure p value? Did you measure p values like probability?
No, in this case, unfortunately, we could not apply the basic statistic since there was the site-specific samples with the addition of the tracer, which give us the opportunity to calculate the standard expand uncertainty according to the guide, according to the instructions.
So you didn't do any statistical tests?
Basically, we did the statistics as the application of the z-test score in order to evaluate the differences between the unfertilized and fertilized soil, where the unfertilized soil was accepted as the blank soil.
Okay, thank you. And another question is about the hypothesis. So did you have any hypothesis before you started your dissertation?
Yes, based on the literature review, we have the hypothesis that the application of the phosphate fertilizer, as I mentioned before, can lead to the accumulation of the natural radionuclides and change in the mobility and availability of natural radionuclides in soil fraction.
Okay, so was it confirmed using your research?
It was confirmed in case of the monopotassium phosphate for the soil from the Almaty region, and in case of the double superphosphate in Turkestan region, and both of them belongs to the phosphate-containing fertilizers.
Okay, but were there any chances that the hypothesis would not be confirmed?
I don't have this chart here. I mean, I did not present it.
Because the hypothesis to be scientific, it should be some probability to be rejected experimentally. Generally, this probability is high.
Of course, you can reject this. This is based on the statistics, yeah. But as I told, not all fertilizers with the phosphate-containing fertilizer has the high amount of the natural radionuclides, or not all of them can change the soil chemistry.
Okay, and what is the impact of your research on chemistry?
The impact, the practical, if this is the practical significance, since the project, since the work was done in frame of the project, we can give the recommendation of use, which was based on the publication of the monography, where you can have the practical significance for the safer agriculture practice and for radiation protection.
No, but I'm asking the impact on chemistry, on the chemical science, let's say.
Impact on the chemistry is related with the sequential extraction, which was applied, and with the determination of the possible mobile and potentially mobile form during the application of the fertilizers.
Okay, but did you try to calculate some, let's say, distribution constants between the soil and water for these compounds, or like metals, radionuclides, which you studied?
But TF factor belongs to the one of them. Yes, this is not the direct distribution between the soil and the water, but we was focused on the transfer from the soil to the plant.
So, but is it possible to use your results for the modeling, for some computational models? Because generally environmental research is very difficult, and such research is expected to give some tools for the modeling.
But for the I guess yes, but for the modeling, I think that we need the more results. It will be not enough to make modeling based only on these results. So this is usually this is the huge work when you are doing the modeling.
Yeah,
Yes.
but at least some approximate models maybe you can propose, I think.
Yes, of course, it could be proposed in future. So this is the task which we can think for the future.
Okay, thank you. So are there any other questions?
Enough question.
Okay, thank you. Then let's go to the next step, and the floor is given to scientific advisors. Dr. Matveyeva, please, the floor is yours.
Good afternoon. We are very happy to present today this work. I know Nurgul almost more than 15 years already. For first time we met when she was first year bachelor degree student. And at that moment, of course, I even didn't think that she will be at this step. When she was 4-year student, she came to me to our laboratory to start her bachelor degree diploma work, and since then she's with us. So more than 10 years she's working in the field of radiochemistry. During preparation for her master degree, I understood that this person is for science because she spent more than 10 hours per day in laboratory in order to achieve the goal which we had at the moment. After the 2 years, she was a technician in our laboratory, and in parallel, we started to prepare the material for her future PhD work. So even not being a PhD student, she started to work on her PhD thesis. At that moment, we consulted with specialists in the field of agrochemistry, pedochemistry, and with our professors in this field in order to have everything as much correct as possible. After 1 year, we were really happy to get financing from our ministry in the frame of the project, and several months after that, she started her PhD thesis. We started to make vegetation experiment, etc., and unfortunately, COVID came to us, and it was a new things to fix for us, and it was really problematic. Anyhow, we passed this step. Also, we got Erasmus financing and sandwich training educational program financing, which allow Nurgul to spend several months, 4 times per several months in Institute Joseph Stefan to make analysis of radionuclides. So quite a lot of this work was done on the basis of these laboratories of this institute, and we are really happy and very thankful to the specialists of this institute for that results which we have seen today. In general, I would like to say that Nurgul is really one of the people who is significant for our laboratory, who became during this more than 10 years as strong specialists in radiochemistry. And if you will ask me what is her contribution to this work, I will tell you that it's really strong one. I even cannot evaluate. She participated in all steps of this project, and starting from vegetation and planting, etc., etc. So all these steps was done by her with our group, of course, because it's a part of a project, and a lot of results still left without focusing in this presentation, even in her PhD thesis, because otherwise it will be too huge. And all questions and recommendations which we have heard today, we are really happy to hear this, but I think most of these things we can include in future our projects, our works, and we really thank you for these discussions, as well as to reviewers who will be after that, for that comments. And I think it will be significant influence to our work in laboratory in general. Thank you. If you have any questions to me, I will be glad to answer as well.
Thank you. Any questions from colleagues? Okay, no questions. Thank you. So then the floor is given to the foreign scientific advisor, Dr. Strock.
Hello, everybody. I would like, first of all, I would like to thank Nurgul for really nice presentation. It was really a lot of work behind of this. So there was one question before also about the statistical analysis. Unfortunately, this radiochemical analysis is so long that it's very difficult to do like enough replicates of measurements that you could do proper statistics, that you could properly implement statistical tools, because typically if you are for instance, you can do maybe 20 up to 40 analysis per week, and if you can see how many samples she had, different soil samples and different also different vegetables and different fertilizers. It was really very ambitious work at the beginning as she set up, and I think the results what she got are really nice. And the main novelty which I see in them is that now we can compare how different fertilizers affect mobility of radionuclides in soil. So as we saw here, by application of fertilizers, you don't increase so much the activity concentration in the soil because you added very little amount. But even this little amount affected the chemistry in the soil in such a way that in some cases we saw significant increase in uptake of radionuclides. And I think this is the most interesting thing which we saw in her results. Other thing is, it was also mentioned if this could be used for modeling. Of course, transfer factors are the main purpose of transfer factors is to be applied for the modeling of the uptake of radionuclides throughout the chain from for instance, from soil up to the human beings. And even here, her results are just another example of that this is really site specific, that these transfer factors are for now the best tool what we have, but it's far away of being perfect because it's really dependent on the soil characteristics also and also on the site where you grow your plants. So if you look at the literature, there are orders of magnitudes span of these transfer factors. We try to classify them according to soil types, and so on. But even within certain soil type, there is a huge variety among them. And I see her results also very important for Kazakhstan because now you have also some site-specific data there are now three locations, but at least something you have. You can now apply models also on using this data for the Kazakhstan. And also about the chemistry, of course, this is tools what she used were basically are not allowing to say much about what chemical processes are going in soil, but soil is so complex, so complex material that it is we basically start with these tools as Nurgul has applied, and now this is very good foundation to go more deeply to study, as Bolat said, what at the chemical and biochemical level really happens in these specific cases. So I think this is now a nice foundation to really know she can now focus more in the future, more to try to better understand what is actually happening, why in one soil or in one fertilization with one fertilizer we see increase or decrease in uptake, or why not. So and I think this is now really nice work which could now be followed in the which could be extended also in the future in another directions. This is about the novelty of the work, and otherwise I started to work with Nurgul, I think in 2019, just before COVID, when she came to Erasmus Plus exchange, and I think she's really dedicated and person and passionate for the scientific work. So she really works hard in the lab, and it's really amazing how much effort she put in her PhD. And I am really happy that I was able to collaborate with her, and we are also looking forward in future collaboration with her and with her team. That's all from my side. Thank you.
Thank you very much. Thank you for clarifying a lot of things. Dear colleagues, do you have questions to Dr. Strok? Okay, no questions. Thank you. So then the next step is we go for reviewers. Yeah, and the floor is given to the first official reviewer, Dr. Krasnoperova. So please, the floor is yours.
Good afternoon, everyone. Review for dissertation work Nursapina Nurgul Arman for educational program chemistry. The dissertation makes a significant contribution to the scientific understanding of radionuclide behavior in the soil plant system under the influence of various types of fertilizers. The importance of the research is clearly articulated in the introduction and supported throughout the thesis by well-formulated objectives, comparative analysis of experimental data, and relevant conclusions. Given the global relevance of environmental safety and food security, the findings of this work contribute to both fundamental knowledge in radioecology and its practical application in sustainable agriculture. The relevance of the thesis is fully justified and clearly supported by current scientific, environmental, and agricultural challenges. The scientific results and provisions of the thesis are completely new. The findings are completely new and present original data on radionuclide transfer and fertilized soils of Kazakhstan not previously reported in the literature. All my conclusions are based on significantly significant evidence. The choice of research methodology is fully justified. The results were obtained using up-to-date scientific methods, including alpha spectrometry and NAA, as well as modern data processing techniques. The results of the dissertation have clear practical significance as they can be used in the development of regulatory documents governing the use of fertilizers in areas with elevated levels of natural radionuclide. The practical suggestions made in the dissertation, such as identification of specific fertilizers that increase or reduce the mobility and bioavailability of natural radionuclides, represent new contributions in the context of Kazakhstan agricultural conditions. The academic writing quality of the dissertation is high. Notes on a thesis. The following comments can be noted. Number one, typographical error in the table of contents on page 2. The section is titled experimental part, which is a typographical error. It should be corrected to experimental part. Number two, incorrect use of a scientific term, the word concertation is mistakenly used in several places instead of the correct term concentration. This error should be corrected. Number three, use of Latin names for crops is inconsistent throughout the text. Number 4, figures and tables do not always include fertilizer codes, SPIN, OM, alongside full names. For either cross-referencing inconsistently, is it advisable that figures and tables consistently include both the fertilizer codes and their full names, superphosphate, ammonium nitrate? This would help readers unfamiliar with the abbreviations. In general, the dissertation of Nurgul Nursapina, titled Entering of Natural Radionuclides in Soil and Root Crops with Fertilizers and Their Distribution in the Soil Plant System, submitted for the degree of Doctor of Philosophy in the educational program Chemistry, has been completed at a high scientific level. This dissertation contains a set of new, well-substantiated scientific results, demonstrates internal consistency, and meets the priority areas of scientific development, as well as the regulatory requirements for PhD dissertation. It is recommended to petition the committee to award Nurgul Nursapina the degree of Doctor of Philosophy in the educational program Chemistry. Thank you.
Thank you. I have a question to you. Why do you recommend to award the degree? At the same time, you said that there are some errors which should be corrected. Because in this case, you could recommend to send for the revision. Yeah, so this is a little bit contradictory. You say that this error should be corrected. Yeah, but then in the same case, you propose to award the degree.
I think it's the recommendations and a graphical error.
No, because if you award the degree, so the PhD student will not be able to correct these errors. So the dissertation will be still with these errors. So that's why I'm asking. So you want these errors to be corrected or not?
Опечатка.
Ну, вопрос в том, рецензент, вы хотите, чтобы они исправили эти ошибки или нет?
Желательно, да.
Да, ну, тогда нужно рекомендовать на доработку.
Нет, this is the typographical error, I think.
Ну, в любом случае, что если, so even if this is typographical error, so if you don't think that they should be corrected, then you can propose to award. If you think that this should be corrected, you can recommend it for the revision. So like, because the dissertation is sent for revision, if there are minor errors which do not affect the content, the conclusions of the dissertation.
Okay.
Yeah, so according to the rules of the ministry.
Okay, I think we should here dissertate Nurgul. Her answers.
Okay, yeah, so let's check what Nurgul thinks about these errors. Okay, thank you. Okay, maybe there are other questions from colleagues about the review?
No
Okay,
question.
no questions. So then the floor is given to the PhD student to respond to the comments of the reviewer.
Regarding to the first question of the reviewer, this is the typographical error, and in my opinion, this is not affected to the scientific part of the dissertation work. Regarding to the second question of the reviewer, there is we acknowledge it, and this is the also typographical error. Regarding to the third question, there was the inconsistency in the use of the Latin names for the studied crops throughout the text is acknowledged. In case of the fourth question, this is the response for the fourth question. The fertilizer codes such as SP, AN, OM are used consistently throughout the figures and tables to improve the readability and avoid text overload. And in addition, this code is fully defined in the list of the abbreviation section provided at the beginning of the dissertation of the reader's reference.
Okay, are you satisfied with the response of the PhD student?
Yes. Я согласна.
Yes.
И на русском скажу, да. Я считаю, что
Да.
это замечания, которые не влияют на общий смысл работы.
Но мы не спрашиваем, влияет оно или нет. Главный вопрос, вы считаете, что их нужно исправить или нет? Или можно так оставить диссертации?
Да, оставить, я считаю, оставить. Просто учесть.
Да. Докторант, вы не могли прокомментировать, вы хотите исправить эти ошибки или...
Там такая угроза стоит.
Зависит, конечно.
Почему угроза? Это доработка, это же положительное решение, просто исправить.
Но это
Если вы
зависит от
сог-
вашего решения, но, конечно, бы не хотелось из-за топографических ошибок уходить на доработку.
Понятно. Хорошо, спасибо. Thank you. Okay, then the floor is given to the second official reviewer, Dr. Edomskaya Maria Alexandrovna. Please, the floor is yours.
Good afternoon, all. I'm allowed.
We can hear you.
Do you
We
hear
can
me?
hear you. Yes, yeah,
Okay.
we hear you well.
Thank you. So my review of thesis, entering of natural radionuclides in soil and root groups with fertilizers and their distribution in soil plant system. Item 1, the thesis was carried out within the framework of scientific project of Ministry of Education and Science of Republic of Kazakhstan, influence of application of mineral fertilizers on accumulation ability of radionuclides and heavy metals in root vegetables. Item 2, evaluation and forecasting of the quality of pot agricultural products are impossible without a clear understanding of the fundamental patterns of the radionuclides behavior in soil plant system. Despite the large number of works devoted to the assessment of radionuclides migration in the soil plant system, this work makes an undoubted contribution to the understanding of fertilizers' effect on the natural radionuclides bioavailability. The significance of the obtained results for scientific knowledge is disclosed, and direction for further use of the research results are determined. Item 3. The self-reliance level the author consists in the analysis of scientific literature data, carry out the vegetation experiment, and analyzing of natural radionuclides in samples using alpha spectrometry method with primarily radiochemical separation, evaluation, and interpretation of obtaining results. Item 4. The relevance of the thesis is well justified in the literature review. The research conducted is important for science. The content of the thesis reflects the topic. The purpose and objectives fully correspond to the topic. All sections and provisions of the thesis is completely interconnected. The solutions proposed by the author are confirmed by research using modern method of physical, chemical, spectral, biological, and statistical analysis. At each stage of the work, the author makes evidence-based and experimentally confirmed conclusions. Item 5. The scientific novelty of the work lies in studying the effect of fertilizers on the migration of natural radionuclides in soil plant system, the effect of 9 different fertilizers on the mobility and bioavailability of natural radionuclides in soil of Almaty and Turkish region was assessed for the first time. An assessment of natural radionuclides uptake by carrot and radishes is given, taking into account the applied fertilizers. The result of the study can be used in developing recommendations for agriculture management. Item 6, the degree of reliability and validity of the conclusions obtained in the work is based on large experimental material, the use of modern extraction, physical, chemical, spectral, biological, and statistical research methods. All the conclusions of the thesis correspond to the task and provisions. Item 7, the main provisions are new and have theoretical and practical significance. The provision 1 is proved in the experimental part of the work in chapter 3.1. It has been shown in table 1 that the fertilizers was determine a wide range of uranium, thorium, and radium activity concentration, which have not exceeded 1000 becquerel. The level of application is wide, since the result can be used in calculating dosing, developing recommendation for agriculture management, radioecological studies, etc. The provision 2 is proven in the experimental part of the work in chapter 3.7 and 3.10. It has been shown in figure 19 and 20 that application monopotassium phosphate leads to slight increase of bioavailable and mobile form of uranium. The natural radionuclides uptake by radish has been proven in the article Effect of Mineral Fertilizers Application on the Transfer of Natural Radionuclides from Soil to Radish in the Journal of Environmental Radioactivity. The level of application is wide, since the result also can be used in assess the intake of radionuclides in agriculture product, calculating doses, developing recommendations for agriculture management, radioecological studies, etc. The provision 3 is proven in the experimental part of work in chapter 3.12. It has been shown in table 30 that the application of double superphosphate into the soil of the Kazimshek village, Turkestan region, significantly increased the uranium and radium uptake by carrot. The level of application is medium, since the results were obtained for one type of agriculture group. Item 8. Considering that the thesis is defended within the framework of education program chemistry, the selected method fully corresponds to the subject of the study. The reliability of the obtained results of the thesis was obtained using modern method of scientific research. Theoretical conclusions identifying patterns have been proved and confirmed by experimental research. Item 9. Information about the natural radionuclides content in agriculture product is necessary for the correct assessment of the level of radiation exposure of the population and biota objects. The theoretical significance of this study is in the comprehensive study of the soil plant system. As a result of the studies, the pattern of behavior of natural radionuclides in soil of the Almaty Turkish region were studied, and the value of the absorption by carrot and radish were established depending on the application of various fertilizers. The practical significance of the work lies in obtaining quantitative parameters of the content and distribution on natural radionuclides in soil plant system using modern chemical technologies for conducting analytical work. The obtained values of the natural radionuclides transfer factor can be used as parameters of mathematical models for assessing their concentration in agriculture product, which is very important to developing recommendation for the use of fertilizers in agriculture for the Almaty and Turkestan regions. In addition, the results of the study can be used to assess the consequences of using fertilizers in agriculture. The conducted complex of analytical work contributes to the development of recommendation for conducting studies for radionuclide migration in soil plant system depending on various edaphic factors. Item 10. The thesis is written competently. The quality of academic writing is high. Also, there are typos and unfortunate expressions. Item 11. At the same time, there are several questions and comments regarding the work. The first one. The section research method on the page 8 describes the method of analysis, but not the study itself. It is not clear the study was conducted in natural conditions or using vegetation methods. There is no description of the statistic methods, as well as the general methodology of the study. The second, page 20, reference 30 and 20 are not listed sequentially. The next one, the methodology of fractionation and bioavailability is poorly described. In paragraph 2.8, sequential extraction procedure is given. Is described to analyze the fractionation bioavailability of uranium, sequential extraction protocol was applied. Question, was there a different procedure for another radionuclides? If so, which one? The next one, figure 20 is turned into 2-page, which complicates perception. Next, in table 12 and 30, the numbers are given with different digits after the decimal point. The last one, page 75, the author wrote, despite that application of fertilizer could lead to the change in the geochemical distribution of natural radionuclides in soil, the transfer factor value was not more than 1. There is no explanation why the transfer factor are combined with the value 1. All values in figure 29 are less than 0.2. Comparison with 1 becomes unclear. Item 12. The main results of the thesis are present in 11 publications, one of them in International Peer-Reviewed Journal Non-Zero Impact Factor, according to the Web of Science, 3 articles in scientific journals recommended by Community of Quality Assurance in the field of education and science of the Ministry of Education and Science of the Republic of Kazakhstan, 6 abstracts at international conference, 1 monograph. Item 30. Summarizing the consideration of the scientific research of Nursapina Nurgul Arman-Kızı, it should be noted that the above comments do not significantly affect the overall positive assessment of the scientific result and its practical significance. The work gives the impression of complete scientific work with interesting scientific and practical conclusions, which importantly form the basis for further research. All the tasks are solved, thus in terms of its relevance, the volume of work, scientific and practical significance, the thesis fully meets the requirements. The author Nursapina Nurgul Arman-Kızı deserves to award the degree of Doctor of Philosophy. Thank you.
Thank you. Maria Alexandrovna, I have the same question actually. Do you think that these errors should not be revised in the dissertation?
I think it's not errors. It's like how to explain. Maybe ideal, but it's all work. It's not ideal. It's just my comments regarding the work. It's not even. It's not error.
Okay, thank you. So the floor is given to the PhD student to respond to the reviewer comments.
Regarding to the first question, respond. The research method section on page 8 is the part of the initiated summary of the dissertation, which in accordance with the requirement for the PhD dissertation formatting is intended to provide a brief overview of the key analytical methods used in this study. A detailed description of the general methodology is provided in the chapter 2 experimental part, including the experimental design, sample preparation procedure, analytical techniques, and the condition under which the vegetation experiment was conducted. Statistical evaluation and data quality assessment are presented in the subsection of the method validation and the following approaches were applied: use of the certified reference materials in the case BCR 320R for the K0 instrumental neutron activation analysis, NIS Urium 4359 seaweed, and IET 375 radionuclides and trace elements in soil as quality control samples for alpha particle spectrometry. Calculation of the measurement uncertainty in accordance with the guide for the expression of the uncertainty in the measurement. based on the ISO guide 98 released in 2008 was applied. Application of Z-score and the N-score as recommended in ISO 13520 released in 2015, statistical method for use in proficiency testing by interlaboratory comparison was applied. Regarding to the second question of the reviewer, respond. The numbering of the references in the dissertation was assigned according to the order of their first citation in the main text. The occurrence of the reference 13 appearing before the 12 on the page 12 is not a formatting error, but rather a result of their respective position within the citation sequence. Specifically, reference 12 is first cited in the caption of figure 1 on page 12. Reference 12 then appears again later on the same page following the citation of the reference 13. Upon review, both references have been cited correctly based on their first appearance in the dissertation. Regarding to the third question, corresponds a six-step sequential extraction procedure was implemented to assess all studied radionuclides, including uranium, thorium, and radium isotopes. The response for the fourth question, the placement of figure 20 across 2 pages is a result of the formatting. The figure itself is complete and legible, and its interpretation is not complicated by the page break, as the access legend and labels remain intact and clearly identifiable. Regarding to the question 5, this is typographical errors, and we are hoping that it is not influencing on the scientific meaning. Regarding to the question 6, respond. The comparison of the transfer factor values with the reference value of 1 is based on the internationally accepted criteria for evaluating the mobility and bioavailability of radionuclides in soil plant system. In radiological risk assessment, the environment, the radioecology, a TF value more than 1 is often used as a threshold indicator of the higher transfer potential. This comparative benchmark is referenced in IAEA documents and scientific literature. For instance, IAEA Technical Report Series number 472, Handbook of the Parameter Values for the Prediction of a Radionuclide Transfer in Terrestrial and Freshwater Environments, and in ANSER 2000 Report, Volume 1. Thank you.
Thank you. Maria Alexandrovna, are you satisfied with the responses?
Yes, I no more question, but maybe I have a little remark. If you
Yes, sure.
Okay. Nurgul, if you start to speak, try start to more slowly. It sometimes very difficult to listen so quickly speech. Thank you.
Okay, thank you. I was nervous.
Thank you. Good comment, actually. Thank you. Okay, any questions to the reviewers or PhD student?
Мария Александровна, можно все-таки, то есть,
Можно на русском.
да, я хотел бы вам вот этот 6-й пункт, вы могли бы так пояснить, что вы это, потому что в целом я так вижу, что это хорошее замечание, но как бы...
Что имеется в виду?
Да.
Ну, обычно, когда идет сравнение, хотя бы дается либо ссылка на какую-то литературу, откуда взято это значение 1, ну, либо приводятся какие-то фамилии, кто это рекомендовал. Если это, допустим, решение самого автора, то он должен пояснить, почему именно 1. Здесь просто я так понимаю, что... Вернее сказать, как я понимаю, что мы все работаем, допустим, в радиоэкологии или в радиобиологии, мы это значение знаем. Но если это говорить о общем, да, мы даем диссертацию в мир, и это могут читать не только радиобиологи и радиоэкологи, нужно пояснять каждую цифру. Вот чисто в этом плане.
Спасибо.
Нету ссылки.
Спасибо, thank you. Okay, dear colleagues, if we have no questions, then we can go to a discussion. So during the discussion, you can speak, and please don't tell how you will vote, because we have the secret poll. And please focus on the correspondence of the dissertation to the principles of scientific novelty, reliability, academic integrity, internal unity, practical impact. Yeah, and if you see some errors in the dissertation which should be revised, also you can mention that. Okay, so please raise your hand if you want to speak.
Рецензенты, пожалуйста, тоже до конца как бы быть, потому что вы принимаете тоже голосование.
Let me start discussion if it's possible. I am not member
Okay.
of that dissertation
Профессор
council.
Мутибаев.
Yeah. And first of all, I would like to congratulate Nurgul and your supervisors with excellent research have been done. And as underlined, Marco, ecological analysis, especially analysis, a very complicated method, procedure, and it need a wide range of analytical skills. And of course, Nurgul, she is a very hard-working researcher. And what I would like to say concerning the applications of that, results of that activity, all the results is very important for Kazakhstan. First of all, we know that our soil is rich for uranium contamination because we are located in the area with a very high level of natural radioactivity. This first one, because it's she investigated our soils. From another point of view, if you look to fertilizers, all that fertilizers are produced in Kazakhstan. It's in Jambul phosphoric plants we produced, and it's very important to us, to all of Kazakhstan residents, how many natural radionuclides, because phosphorus and the uranium are combine each other. If you have phosphorus, you have uranium. This one. And this is the second reason. And the third reason, because we know that the carrot and the radish is one of the main component of our diets. And we are, anytime, every day, we eating that vegetables. And therefore, what I would like to suggest to Nurgul and to Ilona, if it's possible to make such presentation to the local authority or the Jambul authority, and maybe in that cases we could found one of the source of financial, because such kind of investigation will be increase the value, especially if Kazakhstan are going to grow atomic energy, and the 3 atomic plants will be created in Kazakhstan territory. So this is, as for theoretical point of view, of course, a very important value of transfer coefficient. It is very important, and it is, of course, will be included to the database. And for database, such kind value is extremely important, because for radioecology, for radiobiology, the modeling become to be one of the important tools. So from all the point of view, I would like to congratulate again, and I'm very glad that radioecological investigations in the chemical faculty start to grow. I do hope that. So thank you so much.
Thank you. Dear colleagues, who wants to speak? We are particularly interested in the opinions of the temporary members of the Dissertation Council who were invited as the experts in the field. So please, you can say a couple of words.
So may I say?
Yes, please.
A little bit.
Dr. Klivenko.
Yeah, I think it is a very nice work, and I recommend to give the degree to the presenter, but it is a little bit difficult to understand because very, very fast to speak of our today presenter. It is, yeah. But from the theoretical and practical point of view, I think work is very high level, and I recommend to give the PhD degree to the presenter. Yeah, thank you very much.
Thank you.
Yeah, just a couple of comments. Speaking as one who has done the radiochemical separation of uranium isotopes, I know it requires a lot of time and effort. I was really appreciative of the quality assurance section that you wrote in your methods and validated your methods. That's something that's really important when doing any type of analytical work. So I appreciated seeing that. Again, I can understand this is quite time-consuming work, and it definitely contributes to the scientific literature.
Thank you, Professor Snow. Yeah, Dr. Struminska, please. The microphone.
Yes, I agree. It takes a lot of time, and I think everything was done with the art that it should be done. So the work is really well done, well presented. The results are okay, and yeah, I agree with the comment that the speaker should talk a little bit slower, and because the slides were quite huge. But the end, as I looked at this, it took only, let's say, 10 or 12 minutes to present the whole presentation. So it was really, really fast. Anyway, it was understandable, but anyway, with the slower presentation, it would look a little bit nicer for us to listen to this. But anyway, the thesis as it is and results, so it defends itself, so it's well done, prepared. Thank you.
Thank you very much. Okay.
Professor Kenisov, if I can sum.
Yes, okay.
Yeah,
Professor
additional feedback.
Uralbekov, please.
First of all, this is really, the radiochemical analysis is really time consuming. I'm just tell you about uranium, which include co-precipitation, ion exchange, solvent extraction, and final electrodeposition. It's depend on, of course, but to separate uranium from the matrix, it will take 1-2 days, and then we need time to count it by alpha spectrometry. So it's all procedure for one samples to get really precise data. It will take a week. So, and the cost also quite higher for uranium analysis. But today we saw a lot of analysis, and I think that if we will calculate the price of this dissertation, it will be huge, really huge. And also, please add to this using a tracer, radiochemical tracer, which is also expensive, and also radiation issue aspects, and many other things, which is really great work. This which I want to attend to this. But another aspect is I don't know when we need to send this edition for revision. I think, for my opinion, we need to send for revision when we have a really clear, for instance, improper citing in the reference citing. Let's say something, some typo which affect this thesis and so on. Otherwise, we will revise this thesis many times, infinite times. So, which I think that in that case, when we will find in dissertation thesis improper citing, or like improper citing to tables, figures, and so on, and this should be, of course, also this also applicant should say that I want to revise this thesis. It's my opinion, because for instance, really I saw that the value is not given properly, which should be really 1 point something plus minus something. But even if we will send to revision now, nobody will give us 100% that we will not find in these 100 pages another errors. I think that it's just, but it's my opinion. And another moment is publication. She actually has more than one publication, but she didn't include it just because she thought that these publications are not relevant. But for my opinion, they are relevant, at least at methodological part. Journal Environmental Radioactivity. Now I noticed that it's Q3 by Web of Science, but in my early career, Journal of Environmental Radioactivity was one of the prestigious journal, and it was a dream to publish in Journal of Environmental Radioactivity, and it was really hard to be published in this journal. I think that the situation is still like this, to be published in Journal of Environmental Radioactivity, quite complicated at present as well. So I think that the doctoral students was quite fluent in English, but when we heard her supervisor, we see that she learned from her supervisor to be fluent. But really, I think that probably it was better to do slides less and not to be so. So probably next time we present a most important part. Yeah. So finally, what I want to say that I didn't notice during the defense any against things of scientific novelty and other part which chairman was announced. So thank you.
Thank you. Who else wants to add anything? Okay, if not, then I will say a couple of words. First of all, this is a very nice work, published. Results are published in the good journals. Yeah, the presentation was really a bit fast. Yeah, so the PhD student should focus on the main results. So if you have such many results, then you should focus on the provisions. You have only 3 provisions, and then you could focus like 5 minutes per each provision, and then it would be okay. Then you don't need to hurry up. Yeah, so that's like history. That's how it should be done. Okay, regarding the comments from the reviewers about the errors which should be revised. Yeah, so the rules I just shared the screen. We must follow for decisions. Yeah, so the dissertation is sent for the revision if there are minor comments on the text, the correction of which doesn't change the essence of the work. So these are the rules. Yeah, so in my opinion, yeah, this makes sense, because if some errors are discovered, they should be revised. It doesn't say that the work is bad or something. The work is good, so it deserves the degree, but if you found the errors, we as scientists, we should revise them. So it's not a problem. So it doesn't create much problem to the dissertation council or the PhD student. Yeah, and when we consider the second time, so there is no option to send for the revision. Yeah, so we can send it only once for the revision. Yeah, so it is just like a way to correct. So if we discovered something, we just correct it, and then if it's not corrected, then we cannot send it for another revision. Yeah, so that's like that. Okay. So that's all I wanted to say, and then I want to give the last word to the PhD student. So please, the floor is yours.
I want to say thank you to my local and brain supervisor, also to my department, general and inorganic chemistry, to all persons who came today to support me. Also, in addition, I want to say thank you to the Professor Lyudmila Benedict and Professor Radoiko Yachimovich, who support me at IGS. Thank you.
Okay, thank you. Okay, dear colleagues, now we have time for the secret poll. Yeah, so the secret poll will be online via Zoom. So directly in Zoom, you will have to vote. And now I have to transfer all non-members and non-reviewers to the waiting room. Okay, so we will keep only the members. Just a second, it will take a couple of minutes. Bulat Muratovich, please make sure that everybody who is in the room connected to Zoom, because I don't see, we need 8 people.
Сейчас Балхас Галина зайдет.
Okay. Okay, yes, I see her. I see her.
Булат Нурланович, вы ЗУС уберите, пожалуйста, да?
Да, сейчас.
Recording in progress.
Okay, now we have 8 people who will vote. Oh, the Zoom is still here. Okay, we have 8 members and reviewers who will vote. So I just remind you about the voting. So, like 4 options, and you will have to choose one of them according to the rules. Do you have any questions about the poll before we start?
How we will do it? By
Directly in
opening
Zoom.
Yeah, is it a poll or we just vote by hand?
No, we just, it's a secret poll and you will see it in Zoom. So I will start right now and you will see it on your screen.
Okay.
You choose just one option. Okay, here it is.
Okay.
Okay, so we have 8 votes finished. Okay, we finished the secret poll and we are ready to share the results. So here are the results. So 7 votes for awarding the degree and 1 vote for revision and 0 votes for other options. Okay, are there any questions to the results? Okay, no questions. Thank you. Okay, so we are ready to announce the decision of our council. So based on today's defense and the results of the secret online poll, the Dissertation Council of Al-Farabi Kazakh National University awards the degree to Nursapina Nurgul Arman Kızı for the dissertation on the topic entering of natural radionuclides in soil and root crops and with fertilizers and their distribution in soil plant system on the specialty chemistry. So the PhD degree. Okay, congratulations and thanks to everybody for participation in the defense, for the comments. Yeah, and it was the last defense of our council before the vacation. Yeah, so I wish everybody nice summer vacations. Yeah, and thank you again and congratulations to the PhD student and the department. Thank you and bye.
Thank you.
Thank you.
Bye bye. Thank you.
See you then
Thank you,
somewhere
bye.
in future.